Hello and welcome to today's lesson on latent heat. Today we will discuss how heating can lead to a change of state without a change in temperature, and how this heat energy, either absorbed or released, is called latent heat. Next, we will define specific latent heat, which is the amount of heat energy required to change the state of 1 kilogram of a substance without changing its temperature. We will then cover the concept of latent heat of fusion, the amount of heat energy absorbed or released when a substance changes from solid to liquid or vice versa at constant temperature. Finally, we will examine latent heat or vaporization, the heat energy absorbed or released when a substance changes from liquid to gas or vice versa at constant temperature. So far, we have delved into internal energy and state changes. Building on this foundation, we can now introduce the concept of latent heat, which will deepen our understanding of how heat energy interacts with matter during phase changes and the importance of energy conservation in these processes. When we heat a substance, it can lead to a change of state, such as from solid to liquid or liquid to gas. Interestingly, during this phase change, the temperature of the substance does not change. The heat energy absorbed or released during this process is called latent heat. The term latent means hidden because this heat doesn't cause a rise or fall in temperature. Instead, it is used to break or form intermolecular bonds during the state change. For example, when ice melts to become water, it absorbs heat from its surroundings. Despite this absorption of energy, the temperature of the ice-water mixture remains at 0 degrees Celsius until all the ice has melted. This absorbed heat is used to break the bonds holding the ice molecules in a solid structure. Specific latent heat is a more precise term. It refers to the amount of heat energy needed to change the state of 1 kilogram of a substance without changing its temperature. It depends on the molecular structure of the substance and the strength of the forces between its particles. This property is similar to specific heat capacity, but applies to phase changes. Specific latent heat is measured in joules per kilogram. It's a unique value for each substance and for each type of phase change, for instance, melting or boiling. The latent heat of fusion is the amount of heat energy needed to change a substance from a solid to a liquid, or from a liquid to a solid at constant temperature. This process involves breaking the intermolecular forces in a solid to convert it into a liquid, or forming those forces again as the substance solidifies. An example is the melting of ice to form water. Here, the specific latent heat of fusion would be the amount of heat energy required to melt 1 kilogram of ice into water at 0 degrees Celsius. This heat is crucial because it allows the molecules to move more freely, transitioning from a fixed solid arrangement to a more fluid liquid state. Conversely, when water freezes to form ice, the same amount of heat is released into the surroundings. Just like the latent heat of fusion, the latent heat of vaporization is the amount of heat energy required to change a substance from a liquid to a gas, or from a gas to a liquid, at constant temperature. This energy is used to overcome the intermolecular attractions in the liquid state to convert it into a gas. For instance, consider water boiling to become steam. The specific latent heat of vaporization would be the heat needed to convert 1 kilogram of liquid water into steam at 100 degrees Celsius. Even though water is continually absorbing heat during boiling, its temperature remains constant at 100 degrees Celsius. All the absorbed heat is used to change the state, not to increase the temperature. Similarly, when steam condenses back into water, it releases this heat. Here's some interesting extension knowledge about Joseph Black's discovery of latent heat.
In the mid-1700s, I came across an important discovery that would later be known as latent heat. I observed that when I added heat to a substance undergoing a phase change, such as when ice melted into water, the temperature didn't rise. The idea that heat could be hidden or latent without changing the temperature was completely counter to scientists' beliefs at the time. Here was clear evidence that heat energy seemed to disappear into the process itself. Eventually, more researchers began to see the value in my observations and built upon them, helping to develop the comprehensive theories of heat that we rely on today.
In today's lesson, we explored the concept of latent heat and its role in phase changes. Here's a recap of what we covered. Firstly, we learned that latent heat is the energy absorbed or released during a change of state, such as melting or boiling, without changing the temperature of the substance. This hidden heat is used to alter the intermolecular bonds rather than changing the temperature. We then defined specific latent heat as the amount of heat energy required to change the state of 1 kilogram of a substance without altering its temperature. Next, we examined the latent heat of fusion, the energy needed to convert a substance between solid and liquid states at constant temperature. This process involves breaking or forming intermolecular bonds, as seen in the melting of ice or the freezing of water. Finally, we explored the latent heat of vaporization, the energy required to transition a substance between liquid and gas states without a temperature change. Understanding latent heat is fundamental in grasping how substances interact with heat during phase changes. This knowledge has practical implications in various fields, ranging from meteorology and industrial processes. Keep these concepts in mind as you encounter different thermal processes, and see you in the next lesson.